Hi all. In this video we are going to learn about Ishikawa diagram. Okay, this Ishikawa diagram is also called as fishbone diagram or root cause analysis diagram, cause effect analysis diagram, Fishikawa, herringbone. So there are different names for this diagram as such. And why do we go for this diagram? It is mainly for problem analysis, and that too a detailed problem analysis, right? So let's dig into the problem a little bit more. So in this, we will be learning about, what are the different tasks of problem analysis and what should be its input, output, and what do you mean by a cause and effect by using this Ishikawa diagram, and also about how can we identify the various system improvement objectives from this by this problem analysis, right? So that is what we are going to see here. So problem analysis, whenever we have an issue or a problem associated with a product development or a project development, the major goal is nothing but the ultimate goal of this is nothing but system improvement. Say if my company is not working well, I'm doing a thorough root cause analysis over to my situation of the company, and then trying to identify all those issues so that I can find solutions in order to improve my system, right? So that my product could be a better product in the marketplace, right? So that is why, so understand that major problem. So why we go for the problem analysis? We go for problem analysis mainly for system improvement. Okay. And so there are various tasks which you already know. So we need to understand the problem domain, and we need to, let me take my, we need to understand the problem domain. Then we have to identify, the system analysis has to be done. Then we need to gather the requirements. Then we need to update the problem if we want. So we will keep doing all this, all these steps in a iterative manner till we reach the desired system improvement, right? And this is one example which is actually given in the in one of the famous textbooks. So this is called as request for information services. So we basically request for system services because this is kind of a document which will, it's kind of a project proposal. I mean, like we are trying to identify certain problems, we are trying to identify certain input to the scope definition phase, so that we can include what all things what all things we require, what are we going to do, what is the problem, what is objective, what is the directive, and what could be the expected solution. So what all services we require in order to execute this particular plan. So it will throw a lot of light over to what we are actually going to do into a problem analysis. So problem analysis phase require a step called request for information system services. So this will give you a complete understanding about what you have to do in the problem analysis, right? And then comes the problem statement. Say for a particular, so this is also part of the scope definition phase. So there are certain terminologies which you have to keep in mind. Okay, so for a particular problem, when we analyze a particular problem, so there could be a single problem and there could be multiple problems, right? So say if we have one particular problem like this, like order response time as measured from the time of order receipt to time of customer delivery has increased. So maybe you have ordered something, the customer delivery takes timing is actually taken, it's actually almost taking 15 more days more. So what is the problem in that? Okay, so so like that, you have actually identified different problems here. So each of the problem has to be given with an urgency. Urgency is whether at what duration we are planning to complete that particular problem. And visibility is nothing but whether it has got a high visibility, medium visibility, or low visibility. So when you look at here, there is a general lack of access to the management and decision making information, and this will become exasperated by the acquisition of 2 additional order processing systems. So but say if you don't have budget at the right moment, you have other things to be taken into consideration, then this could be kept. Once you are making everything streamlined, then you can actually look over to it, right? So you can give more time for it to be achieved, right? And this is the annual budget or the benefits that you will get, and how you are actually going to prioritize your. So there currently exists data inconsistency in the member and order file. So first, this is the first priority. So you need to check whether it's actually is there or not, and you need to analyze this particular problem first. Now the proposed solution is nothing but, so when you analyze this, so it's like a quick fix, like, so probably you could come out with a new development pattern so that you can avoid this particular issue. So for each of the issue, you are identifying the time duration, the visibility, the the amount or the cost associated with, you're prioritizing all the different tasks, and what would be the expected solution out from it. So this is kind of a problem statement, right? So now when you look into the cause and effect analysis, so when you look into the cause and effect, how cause and effect analysis is going to actually help it, right? So each and every problem you're actually going to take it and you're going to analyze it. So how can you analyze it? So if you have a cause, that you have something, you know, if something happens, what would be the result, right? That is nothing but cause and its effect. It's, you know, what would be the resultant of this particular action? That is nothing but cause followed by its effect, right? Cause is something, why that happened, and you know, what happened first, and you know, what is the result of it. So what happened because of that, you know, what happened to the company, you know, something. So the order delay is happening by 15 days, so it's delayed by 15 days, right? So why is it so? You're going to dig into the problems. So this is one particular example which is actually given here. Peter fell off his bike and broke his leg. So if something like that happens, you have to clearly identify that Peter fell off his bike. So this is the cause, right? And what is the resultant of that? Result of that is he broke his leg, right? So this is the effect of this. So for each and every problem, you need to identify what is the cause and what is the effect associated with it, right? And there are certain examples, you can actually go through it. And then comes the Ishikawa diagram. So why we require this Ishikawa diagram is that, so Ishikawa diagram basically could be done in different ways. And for our course, you know, basically we uses this 6M templates. So Ishikawa diagram is also called as a fishbone diagram, and Ishikawa is the person who found this diagram. And the fishbone diagram, because it looks like a fish, that's why it's called as a fishbone diagram. And this is one of the most you know, common tool which is actually used for problem analysis. So say you will have multiple problems, so each of the problem will be written at the head of the fish, and the causes will be identified based on the category. So 6M is nothing but the 6 different M categories that you have actually identified. So you have methods, machines, manpower, mother nature, materials, and measurements. So if you have a problem, you will look into all these different perspectives, like from the measurements perspective, what made this, you know, what is the cause in terms of measurements, what is the cause occurred which in terms of methods, what is the cause of, in terms of machines, like that you will look into different perspective and you will identify the different causes. Now is this the only method which is available, ma'am? No, you do have 5 wise methods, and you know, there are different type of 7M method. There are different type of methods which are available, and you can even come out with a number of the categories according to the you know, according to how big your problem is. And say sometimes your problem require a special category which has to be considered specially into your problem. Yes, you can do that. So it is not predefined, but in order to make our life simple, and in order for you to have a hang of it, you know, we are using this 6M's template. So for your course, you have to definitely use this particular template. And so this is the Ishikawa diagram. So in Ishikawa diagram, if you could see that, you can see a fish head and a bone, and you could also see you know, the fish tail, right? So when you look at it, say my problem is always written the head of the fish. So my problem here is increased fuel consumption. So I will look into this increased fuel consumption in terms of the first M, that is method. So probably my way of diagram is driving is really bad, that it increases the, you know, fuel consumption, or in correct gear I am putting, you know, I'm driving in the second gear for a long time, so that, you know, fuel consumption is more, something like that. Say if it is a manual driving, right? And measurements is like incorrect tire pressure. My tire pressure is, you know, supposed to be 32, but it is actually 40 or something like that. So you know, some, you know, I do have some issues with my tire, and ignition timing is not adjusted properly. And machinery, my car is my vehicle which I'm using is having some worn out parts which has to be replaced, but I have not replaced yet. And materials, so incorrect petrol octane or incorrect engine oil which is used for the materials, right? And manpower, maybe, you know, the driving skills are bad and the maintenance happen, you know, whenever there is a service to be given, I'm not giving the you know, vehicle for service, etc. And harsh weather or something like that. So sometimes I'm taking my vehicle for a trekking, which is not supposed to be a vehicle which is used for trekking, right? So it could be, so all this could be, you know, certain issues. So when you look at this particular diagram, so this is as simple as that. So Ishikawa diagram is one of the simplest diagram which you could see. So you can have multiple problems, right? So increased fuel, so So whatever be your problem, that problem statement will come over here. So for each of the problem statement, you have to look into this particular problem and identify the causes based on all these different categories. So that is how you have to do. That's such as simple as that. But once you do this, you identify the various causes, and you know that which all problems could be actually given a particular solution, so that you can improve your whole system for that, right? And now maybe what do you mean by system improvement objective? So whenever you think about yes, I need some system improvement by doing this problem analysis, what I exactly mean? Okay, so what I exactly mean is that I want my success rate to be better, right? It's kind of a success measure. I mean, like, say the fuel consumption is more now, I need to reduce my fuel consumption by 13%. Okay, so that could be my objective, or reduce the response time, or decrease the deaths, something like that. So whatever, so you are actually having a very clear picture about what percentage, or what is the exact amount that you're going to reduce. So that kind of an approach is nothing but system object. So by doing this problem analysis, you clearly know that if you find out a solution for that, what could be the increase, or what could be the increment or improvement that I could see in my system, right? So that is the best thing which you have to understand. And of course, within the constraints, so you will have some schedule constraints, you will have budget constraints, you will have technology constraint, right? So considering all this constraints into account, what is the objective that you are actually aiming at by doing this problem analysis and for the system improvement. So as you all know that we have seen this problem statement already. So say we are taking this first problem statement, order response time, right? So we are taking this first one itself. So order response time is unacceptable because it's taking like 15 days of time after order, which is actually unacceptable, right? So what could be the cause and effects for that? So throughput has increased, and system is too keyboard dependent. So data editing performed is very low, and warehousing picking tickets is like something, the order is actually given, but it's not properly identified in the system. So there could be various costs and its corresponding effects, right? And in the system improvement objective, you will have a system objective and the constraint, right? Because you need to know. So throughput, say I want to decrease the throughput time. I mean, like I want to decrease the time required to process a single order by 30%. So I have very clear objective on that. And there will be no increase in the order processing workforce. So I'm not going to increase my workforce, but still I need to make this faster, this whole thing faster, right? So like that. So you are actually, what are the objective and what are the constraints for each and every objective. So that is actually given. So but if you have a problem analysis sheet, and if you have a problem statement sheet, and if you're given this system improvement sheet with the cost effect analysis and system improvement objective, you have a clear idea that what you have to do. So all the steps are really, really clear for you by this whole process, right? And even for this system improvement, basically you can even have a chart. I mean, like you have a template for that, basically, like what's the executive summary, what's the background information. So by looking at this, you will have a clear understanding about what are the problems, what are the constraints. So say performance problems, opportunities, cost and effect analysis, so information problems. So each and everything you are actually giving this. So you are categorizing it into multiple categories, and you have a clear idea about what are the issues associated with your problem, and what are the things which you have to do in order to improve your system in a better way with the constraints with the constraints considered at the right time. So let's see some examples here. So these are certain examples which I got from the net. Say one example problem that we are going to see is that late pizza delivery problem. Okay, say if you get some late pizza delivery problem, you could just think about it. So these are the issues. So it's at the head of your fish, and these are all the 6 M's that we are going to consider. So we are going to think in terms of material. Maybe we didn't get the right ingredients, right? And ingredients got over. And then measurement, new employee don't know the size of the pizzas, and machines, oven is too small, car broke down, and some of the employees were not available, and drivers get lost during they were not able to identify the GPS connection got lost, right? Poor order taking, and you're not fast enough to take the orders, and the rain and the other things which made the drivers not reach there at the right time. So these are all could be the issues. So this is even a bigger chart where it actually tells you a lot of other problems also. So it's kind of a detailed one which you can actually go into it. So how to create the customers there are so many things. It's about the poor customer service, and this is also related to the pizza delivery itself. Okay, and now another one is flight delay problem. So this is one small probable solution which you could think. So the ground stuff is not okay, so the reliability of the crew is not fine. Bad weather, bash and fog or something like that, and the various methods which they have used, I mean, like the baggaging loading is slow, and unscheduled maintenance came up, and limited stock of spare parts, and fueling is slow, something like that. Then management issues could be there. So I mean, like military, I mean, like VVIP priority came up, and something had delayed, and cancellation, late arrival. So all these things are different things. So when you have a problem, the only thing is that you have to think in different perspectives, in all the six different perspectives, to identify the causes, and you can actually write it in detail. So this is again the product contamination. So maybe so in terms of environment, maybe some, because of the rain or the humidity or temperature, the things get ruined. And the methods, the procedure which is used is not followed or not correct, or some sampling error happened, right? So for each one, say for procedure, you can have subcategories as well. Say for, you can have major categories like this, like procedure, sampling, but you can also have subcategories. So poor hygiene, then ineffectively trained. So ineffectively trained, okay, training is not there for proof of training, experimental training, so all these things. So you can have subcategories as well. So materials used after the expiry date, it's dirty, and raw materials contaminated, raw materials itself contaminated. Then machine, it is defect or worn out or not validated, maintenance is not done properly. So all those things, so this is all examples for Ishikawa diagram. So now one example which I wanted to show you is that so this is exactly the Visio. This is called as a Visio. It's like the Microsoft Professional, which you could see. So this is actually Visio Professional, and if you could take a blank drawing, okay, it will look like this. Okay, it will look like this. So it will give you actually the shapes. Okay, so if you wanna look at the Visio, this is kind of the general diagram, you could actually see. So this template in Visio is available to download from the internet itself. So you can use this diagram, and then you can update for any kind of the problem itself. So flight delays, it will be written in the things, and see here there are categories here. These are the categories which are given. So this categories from the down is using this category 2, and categories from the up is basically using this this one is nothing but this category. So when you look at this one, this is actually your category 2, right? So like that, and this is the fish frame which you are using actually for this, and these are called as a causes. So these are the primary causes, and you can also have secondary causes. Secondary causes, say if I have a secondary cause from here, I can actually I can actually put it here and put it over there, so that I can have a secondary cause from here. Say in the crew shortage, maybe they have not, recruitment is less, something like that. So I can actually include that recruitment is less. Okay, I can actually give that here. That is also possible. So like that, actually I can write, and I can recruitment is less. Okay, or they have done something like that. So such kind of issues could be done, I mean, like I'm just doing this here. My recruitment is less. So like that, if I want to actually give some subcategories for this, that is also possible. So this is how you will give the subcategories, and you will actually and all the causes will be actually looking forward to this flight delay, the problem statement, because it just means that all the problems basically contribute back to this flight delay, and all these different categories are actually given here. This is the fish frame, and this is the primary causes and the secondary causes, if you could see. So that's all it is. That's all about your diagram. So this is as simple as that, and you can also have PPT templates which are easily available for you to download from the internet. So this can also be used. So these are the sub problems here, and these are the major causes and the sub causes here, and these are all the categories which you could see. So you can just fill in here, and here is, this is a problem statement where you have to fill, and that's all it is. So this is all about the problem analysis part in Ishikawa diagram. That's all it is. So when you look at the problem analysis, we do this problem analysis in order to in order to identify and critically analyze, you know, what is that we have to do in order to get a system improvement done. And for the system improvement itself, you have to do a proper cause and effect analysis, and you have to also do the system improvement in two things. I mean, like, you should know the clear objectives. The system objectives has to be clear for you. At the same time, what are the constraints that will be that you have to consider for each and every system improvement objective that you have identified, has to be identified, right? So that's all it is. So if you have any issues or anything like that, you can always get back to me. If you have any doubts, you can, you know, check in the comment box. That's all. So have a nice day. Thank you so much.